Let's have a closer look at some technical details ahead of the Italian Grand Prix 2023. Traditionally, Monza is a high-speed track and teams bring their lowest downforce configuration to Italy. And let's start with Red Bull, because they didn't bring a super skinny rear wing like many others. Their top speed and DRS advantage is already a huge benefit, so they kept a higher downforce level for higher cornering speeds and less tire wear. Interesting to see are their two different approaches. Verstappen's car uses a standard wing without gurney flap. Perez's car has a chopped-off trailing edge to reduce downforce and a gurney flap to increase the downforce level again. To maintain the trailing edge thickness after cutting, these profiles have a constant thickness at the back. So these are profiles especially designed to be chopped off. The block you see next to it is a so-called Kleino block, which you can use to measure the angle of the tag with an angle meter. Ferrari uses a very straight and super smooth rear wing. These wings are very efficient because they are straight and the force vector points down, so they produce downforce. Any angled sections produce some side force and hence less downforce, so you want to avoid that. They don't use a gurney flap here, but they are experimenting with different beam wing configurations and use a gurney flap here. A double element beam wing helps to pull the flow further up, because it's introducing fresh air with a gap in the middle. Like we discussed in my earlier videos about Red Bull's drag advantage, a single beam wing is stressing the flow more, because no fresh air is being introduced halfway. So if the support of the rear wing is gone, because DRS is enabled, the flow is likely to separate, which results in less downforce and hence a bigger DRS drag advantage. McLaren brought probably the dream wing of all aerodynamicists to the track. A beautiful straight wing with fatter leading edge for less angle sensitivity. And because it is so straight, you can fine-tune the slot gap pretty easily, which results in better performance. They also flow-vised this wing, but we cannot see much details here. Also, McLaren uses a single beam wing element and another element to support the rear wing above. Also, they brought a rear wing end plate infill to reduce the end plate's expansion, which in return reduces downforce and hence drag. Aston Martin also uses the cut-off approach plus gurney flap, and they use flow-vis too. We can see the point of highest air speed, which sits nicely above the diffuser exit to create more downforce. Also, Aston Martin tried to slim down their drivetrain as much as possible to give more volume to the underbody flow. Alpine uses their wobbly wing approach again on the low downforce front wing to balance the reduced downforce at the back. And, that's very interesting, they use cotton threads on beam and rear wing to analyze the flow. As long as I can think, I've never seen cotton threads on an F1 car, but it's a nice and simple way to analyze the flow. You will need photographiers around the track or cameras to see their behavior. Also, it shouldn't rain, otherwise they stick to the surface. But their advantage over flow-vis is that they show you the aerodynamic behavior in every corner, while flow-vis is drying during the lap and showing you a summary of a lap. Mercedes went with the cut-off approach as well and introduced a, by the looks of it, 3D printed winglet to avoid cockpit losses from spilling out. Alfa Romeo came with a new downwashing front suspension like Mercedes, and they tried to get their tires up to temperature within 1 lap now instead of 2 laps. Also, they brought a nice flat wing without gurney flap, and they have a special livery to promote their new 33 Stradale. More on that in my other video. Haas also showed a cut-off approach on their rear wing flap to reduce downforce. So they don't need to modify other parts of the rear wing to reduce downforce and hence save money. And AlphaTauri uses super small beam wing elements. So they don't work with an increased DRS effect, they are working with less downforce overall. And if you want to learn how to design an F1 car, check out my online courses with the links below. See you at the next one.